welcome. Keep talking.
Yeah, you just sounded like you were
To the people.
on basketball. But I was
How are you, Dr. Batts? You're welcome. School colors.
Yeah,
I don't
sounds
know.
like it's quite positive.
How's your no, you're like different place. How's it going?
7 years.
Same thing?
Where are you from?
I'm getting to Oklahoma because I interviewed last year. They said just COVID or
Yeah.
the other paying for it, so if they're paying for it, that means I think they're really not. Transportation, surprising. Is like rough and time. I think like structural transportation mostly. You kind of wish bridges?
Yeah. Right.
I mean, you learn those, you learn those things in the field and in the classroom. Exactly. So it's like, doing foundation work right now. I don't think they before, dude. Maybe learn.
Yeah, okay.
Okay.
Whatever you do, our foundation is what you do for your.
What's your first name again?
At least it's
How you doing? How are you? Your first name is? Joshua.
Yeah.
This is
I'm William.
William. Hey, man, William. I'm Johnny. Nice to meet you. Yes, sir.
I know some people from my work. How do you like that? It's cool. It's just that it breaks too easily. I like the design of it, but like I took a food detector, but then we decided to get another one. No, it's just one.
He was
Like he's into it. So I was like,
Oh, yeah, which was like more right up the middle, they got the top. So you guys were talking about.
I don't know about it personally. It's not like a hard surface. I was thinking about like upgrading, but then I'm like, what's different?
managing director is position.
Already promising is that I'll be the guy getting all the tech products. I'll take all the heat, do the people.
Animal services.
Yeah.
Role to keep that, you know,
We
under the
were
radar.
at a conference.
Okay.
That's kind of.
Well, yeah, so they made managing director when he was tired chief.
Yes.
They were, but now he's retired from fire chief, and they said, you know, we want you to stay on, so then I saw him retired from that. But he's also.
You're gonna go Parkville then?
Yeah,
I don't know.
He's on what force, he's
He
on.
does.
Okay, I will.
I don't know.
Okay, I will.
Their H and H department. I don't want that for papers, because I want to go from.
So they haven't, appointed
Your
one,
master's in,
so
water
Chief
resources.
Foley is still interactive.
There's another one that I couldn't hire, just ABCE, artificial intelligence.
So I don't know what they're waiting on, we're in the situation actually right now with our chief as well.
I have a master's too, but I'm just looking into the health nutrition.
I don't know what they're waiting on.
The company in Oklahoma does it, but I haven't asked them about it. I interviewed with a company in Oklahoma, they connected with one of the engineers who helped us build the product. So, they go visit the information. Hello, I'm Bobby. Nice to meet you. I love where I work right now. I could be making somewhere else.
Travel partner.
No.
That was a travel partner. Well, congratulations on that travel. That one was a doozy.
Yes, I graduated.
You second one of these two chairs
Oh, sure.
in the second row. I just want to see if I can't see the chairs, but
Yes, sir. No problem.
yeah, let's see what these are. We have an uninterrupted view of the main show.
Built up the name.
I invited these guys. Oh,
All right.
I
You ready? You got it. Here, I'll
yeah, there you go.
How you doing?
Pretty good. Oh, yeah. Because you'll want to. If it was just gonna be my friends and my parents, we're chilling.
Who's our other
Ready or not?
I don't know. Some say he's only there when you're not looking. If a tree falls in the woods.
Hey.
Dad falls in the woods.
Yes, sir.
Dad falls in the woods, he doesn't come back. For the rest of the semester.
Darn it, we were so sad.
Oh, I'm so sorry.
I'm just let David do it. It's on the way. Somebody read
Oh.
Hello, folks.
So it says Nike Nike on the box. Thank you.
On the Congress.
He'll be there.
No, you can be. Yeah. Yeah. Don't worry.
Hello, good morning, everybody. My name is Dr. Aldo Villon, and I'm honored, and I have the privilege to work with these amazing students this semester in the fall civil engineering capstone course, which is the last course they take before graduation. I would like to first welcome all of you and thank you for putting time and coming and support our students. And also thank our clients, which is the fire station department of San Angelo, especially Chief Patrick Brody. Also to the City of San Angelo engineering, the engineering service, engineering department, Colin Baggett. He facilitated the connection and helped us with the standards. And basically the project that the students are going to present, site development for fire station number 9, which is projected to build in the next few years. As we're seeing growth in the south area, south part of the city. We need to have fire stations at Pueblo City. So I will present to you the theme for this semester is DWJ with Fire Station 9 site development.
Good morning, everyone. Thank you for that kind introduction. We want to thank everyone, first and foremost, for being here this morning. I want to thank our faculty, the design professionals and other professionals, community, and friends and family for being here. We really appreciate your attendance this morning. Here, we are going to present to you this morning the site development for Fire Station number 9. I am Joshua Weekland.
I'm William Kerr.
And as you've already met, our senior advisor, Dr. Pignon. I didn't take it. I was team lead for this project, and as well as the transportation lead. William took lead on hydrology and hydraulics, as well as construction and environmental. Our client requested that DWJ Engineering design a site development plan for the proposed fire station number 9. Now, this project would consist of 3 primary design efforts. The first being a drainage plan. This would include grading of the site, as well as an existing and proposed drainage analysis. Secondly would be a site layout plan. This would include areas such as parking and driveways, and designing a pavement thickness. And lastly, a construction. This would include things such as an erosion control plan, a construction timeline, and an opinion of probable cost. As you can see here, this is the general site location of our site. It is located in the southern portion of San Angelo, near the country club. Now, the southern portion of San Angelo needs a fire station because of emergency response times currently. Current response times are in the area 6 to 10 minutes, when we would prefer if they were 5 minutes or less. Zoomed in here, we can see that our site is in between Ben Ficklin Road on the west side, and on the east side is Frontage Road. Our site is also north of the Crossings Avenue and the Attorney General's office here, and it's only 2.97 acres. When considering this project, we met with our client and discussed some requirements that would be had for the civil site design. One of those being parking. We were required a minimum of 12 employee parking spots. This is due to the fact that they work in 6-man or 6-person shifts. These 6-person shifts overlap, so 12 employee parking spots are needed. Secondly, landscaping. This is more of a maintenance issue. The people who are on shift have to maintain the grounds. And so our client wanted to minimize, our client wanted to minimize the amount of maintenance that would be had on things such as leaves when they fall in the fall, and lawns that would need to be mowed. Our client also wanted 4 engine bays, more on that in a moment, and concrete pavement. This is opposed to a flexible pavement like asphalt. This would give us higher lifespan of the pavement. And lastly, the flow of traffic. Our client wanted the flow of traffic to go from west to east. The fire trucks would enter the engine bays from the Ficklin Road, so from the west, and then they would exit out on call onto Frontage Road. Now, after considering those requirements, we also had to think about the site itself. We have some constraints from this location that was chosen. First being the property line. If you notice the triangular or sawtooth cut in the property, this is not a part of our property. This is not owned by the city and therefore could not be used in. Now, how does this constrain our design? Well, simply it pushes our driveways north in the site, which pushes the rest of our site north on the lot. Secondly would be elevation. There is quite a drastic elevation change on the site. This is due to the previous owner. The previous owner also owns a lot to the south, and when that lot was under construction, the soil that was cut from there, instead of being hauled off out of the city or to a different location, was hauled off and dumped here, giving us quite a big high point in the middle of our site. The difference in between elevation from Frontage Road to the middle of our site is approximately 2 feet. Now, the difference between the middle of our site to Ben Ficklin Road is 8 feet. And then the greatest difference is when we consider the existing retention pond. Now, this existing retention pond is not within the bounds of our property. It is a separate property not owned by the city, will not be owned by the city. And the difference between elevation of the general proximity of the middle of our site to the bottom of the retention pond is around 18 feet. Now, these elevation differences will put some constraints on our design in regards to drainage. More on that here in a moment. Now, just to give y'all a little bit of a view, this is taken from the proposed location, and as you can see, the existing retention pond there. This is looking north. Now for William with hydrology and hydraulics.
Okay. Moving into hydrology. For our scope, we are to provide to our client a drainage analysis of both the existing and proposed runoff flow, as well as a way to mitigate that proposed flow. We are also, for our scope, to provide a grade plan that we worked hand in hand with transportation to mitigate that flow where we wish. Run it off. For the design standards we used the City of San Angelo Stormwater Design Manual to find coefficients and constraints such as the runoff coefficient and the time of concentration constraint, which we will cover in a bit. We also used the Water Resources Engineering textbook by Larry Mays for equations and calculations. And then we used the Civil 3D program. We used its hydrographs and hydroflow express programs to study the amount of flow and how it's discharged, as well as using Civil 3D for the grading in itself.
And Excel.
For our design methodology, we used the rational method as the site doesn't go over the 200-acre limit. It was the best method we could use, is the rational method. We also used the level pool rating method for studying the existing retention pond, as well as the Manning's equation.
So here you can see our existing drainage area. Shaded in this light orange area, we have the entire drainage catchment that flows to the existing retention pond, roughly 2.86 acres. In the blue shaded region, this is the entire area that drain to the drainage ditch alongside frontage road, 1.79 acres. Now, when considering our design options, we thought about two. The first being to keep the same drainage pattern that is existing, that is, having a high point where our building would be located, and draining a portion to the retention pond and draining a roughly even portion to frontage road. The second design option, and more on that in a moment, the second design option would be to grade the site in a way that we get as much area of the site draining to the existing retention pond.
Going for our existing drainage data, as you can see on our right is the graphs for a 100-year storm for both catchments, with the x-axis showing the time of the storm and the y-axis showing the amount of flow during that storm. Now, as you can see for both catchments, both of them have a time of concentration, which is very important for managing flow and regulating flow. The reason that both catchments have a time of concentration of 10 minutes is that due to in the storm water design manual, it states that if calculate a time of concentration below 5 minutes, 10 minutes, we are to jump it up to 10 minutes for any other calculations for the peak flow. That is why we have those there. For the west catch includes the existing retention pond. It has a peak flow about 705 cubic feet per second. And then for the east catchment, which includes a drainage ditch running along frontage road, it has a peak flow of about 4.41 cubic feet per second. Now, using Excel as well as the topographic maps provided by the city of San Angelo, we were able to find the volume of the existing retention pond. And this retention pond is very important as it is the primary source of drainage for our west catchment. On the x-axis, it shows the volume of retention pond based on the y-axis, the amount of head that the retention pond has. The head going from the bottom elevation to the top elevation, to the top of the elevation being the surface water. Calculated that the total volume that the retention pond can hold is 2.64 acre feet, and the maximum amount of water head being 7.5 feet before it spills over. Within the retention pond, there is also a black polymer culvert pipe that has a diameter of 2.5 feet and stretches at a length of 45 feet going through the side of our retention pond. As you can see from this picture, it shows a cross section of that retention pond where the culvert is placed, and currently it is showing you the water flow of that blue area, the water flow of about 7 cubic feet per second entering. This graph was also given to us. We used to calculate with Hydro Express, which was the Civil 3D program used for designing culverts.
Here we can see our proposed drainage areas. If you notice the west catchment, which beforehand was quite a bit smaller, we now have increased the area. After analyzing our retention pond, we decided that it would be best to try and grade the site in a way that directs stormwater runoff to this existing retention pond. It could handle the capacity. So here we have the lightly shaded orange area being the west catchment, going from 2.86 acres now being 4.15 acres in the total area. And as you can see, the small portion of the catchment that flows to the drainage ditch near frontage road has decreased in size as well, or not as well, it has decreased in size.
Now here is our proposed drainage condition, drainage data. Once again, there is our hydrographs as I did with the time on X and the flow on Y. As you can see, there's a major difference with both hydrographs. Based on lap time, which might have been hard to differentiate the two, There's a huge difference with the peak flow. With the west catchment, we were able to calculate a concentration time of about 16.3 with a maximum amount of peak flow being 13.9 cubic feet per second, near double of the existing flow. For the east catchment, since there was a reduction in area, we were able to lower that rate down to 1.1 cubic feet per second with a calculated time of concentration of only 13 minutes. Now here is our level pool routing method. Now with this graph over here is a post-development graph showing the flow rate of both as the hydrograph of the 100-year storm for the 13.9 cubic feet per second spike, as you can see in that line, and the orange line represents the amount of discharge exiting the culvert during that time. For pre-development, as mentioned earlier, we had a peak of 7.05 cubic feet per second, and the culvert itself has a peak discharge of about 1.31 cubic feet per second. And with this retention pond for post-development, we go from 13.9 cubic feet per second of runoff to only with only a discharge rate of about 6.8 cubic feet per second, reduced with it going from more than half from existing to being less than half for discharge, with about a detention time of about 2.1 hours.
So here we have another view of our proposed drainage areas. And now we have overlaid the, wrong button. Now overlaid the proposed site layout. Now, some design constraints that we need to consider. I mentioned beforehand the elevation difference. One of the constraints is related to this retention pond. So the maximum slope, according to City of San Angelo Stormwater Design Manual, is 20%. Currently, that the existing pond sees slopes of anywhere from 40% to 60%. However, whenever we are to grade our site, we are going to design in a way that our portion of that retention pond meets city standards. To do this, we essentially had to decrease the elevation of the building. So from the edge of the building to the edge of our property line, for existing conditions, we had a difference of approximately 5 to 6 feet. Now, with this height difference, if we left it as is, we would have to do two things. We would have to install a stormwater drainage system on site that outflows into, or that discharges into the retention pond. And we would need to design a retaining wall that would be, if not under the building, very close to the edge of the building. Now, retaining wall would not be simply holding back or retaining soil, it would be a structural foundational element of the building. Due to the costs that this could incur, we found that lowering the site elevation, or the finished floor elevation, essentially the building slab, would help us to meet this slope requirement for the retention pond. Now, if we decrease the floor elevation of the building, we now have to consider something else. If you look in the northeast corner of our lot, we have a high point. This is just another, it's a berm. More soil is here, and if you can see the contours, more on that here in a moment. With this high point, we decrease the floor elevation of the building. We now cannot drain water to the north. We cannot route water to the north of the building. So, this is what we did. essentially, we created a high point at the south of the building, a ridge, to direct stormwater runoff to the left along this gutter line, up or north to these curb cuts. Now, stormwater runoff on this side of the building, more of the right side, will run along this gutter line, will run north along the site, through our cut, and through these curb cuts. Now, we mentioned the maximum slope of 25%. In its current conditions, we had slopes of 3-to-1, or roughly 37. So we were not meeting. So we had to find a solution. Also, we created an open channel flow system. And so we had to analyze that and determine and make sure that we were not exceeding regulations. So this is our solution. We considered a trapezoidal concrete flume. However, we determined that was not adequate. A trapezoidal flume would increase in width faster than it would increase in depth. We found that, however, a rectangular flume, since it's rectangular, does not increase in depth. We set the depth, the width rather, and we can determine our depth. We have a requirement of like I said, a maximum of 25% or 4-to-1, and we need a minimum freeboard of 12 inches. So for our open channel flume, this means from top of the flume downward, that 12 inches needs to have no water flow in it. And we need to not exceed a velocity of 20 feet per second. So designing a 1.5 foot wide concrete flume, we found that it can have 9.6 inches of water flow. This gives us our 12 inches of freeboard, and it allows us to match existing grade with a 4-to-1 or 25% slope. Now, we also considered not having a lined open channel, so not having the flume or putting any concrete there. However, another reason why we thought this would be the best design is because of our Froude number. The Froude number, anything greater than 1 indicates a likelihood of erosion. So in an open channel flow, we need to ensure that we are not eroding the area. I mean, think about it. If we're on the north end of the building, if we're eroding out the area all the time, then that building we're gonna undercut the building. So we found a Froude number of 1.08. This is slightly greater than 1, so it's not too much concern, but just to be safe, we decided to line this open channel flume in concrete with this rectangular design. And here's just so we're clear, here's a zoomed in portion. As you can see, our entire site, this north end, as you can see here, here's the berm, and then our building, berm, and our building, and they slope down to this open channel flow. There'll be a steel grate over the top of this so someone doesn't stick them and break it or something.
Moving on now, design for our drainage. We found that for the west end, we were able to, thanks to the existing retention pond, meet the stormwater design manual standards, since we were able to get our 13.9 cubic feet per second flow to match the 7.05 cubic feet per second flow, since we were able to reduce it to 6.8 cubic feet per second. We were able to get those flows relatively close to each other match, where both runoff for existing and proposed are close to each other. Like, not exactly the same, but you can see it's like just 1, maybe 2 cubic feet per second difference. Now, another thing to mention is that in a residential area further to the west of our project area, they have mentioned that they've had drainage problems as most runoff goes through the area to get to Concho River. and they had some regards, like some worrisome regards of our project. And though the retention pond itself is outside of our project area, which means we have no regulation or no way of redesigning it, we weren't able to really work with it. But if the city or if anyone else goes over there to redesign the retention pond, we recommend either shrinking the size of the culvert to limit the volume coming out at a specific time, or creating a standing head pipe, which is essentially rather than have the culvert being through the side, as you've seen from the cut section, rather than the water going straight through, you would hold the pipe up at about a higher elevation where the water would have to then be retained within the retention pond and then flow over the top, holding more volume in that retention pond. For the east catchment, initially it already had a low flow, already meeting the standards for the city, the stormwater design standards. And since we've decreased that area, reducing that flow, essentially the design itself is, we don't have to design any stormwater system or any drainage system over there. It was already meeting standards before and after our design. Now on to Josh for transportation.
So for the transportation discipline of this project, our scope included a parking plan, a driveway plan, and designing the pavement thickness. In doing so, we complied with standards. One being City of San Angelo specs, in accord with their stormwater design manual as well. The 2021 International Fire Codes. We followed ACI codes for our pavement thickness, and we ensured that the entire site was ADA accessible. So first, parking. We considered 45-degree parking and parallel parking, but after meeting with our client, we agreed that 90-degree parking would best suit our client's needs and the fire station's needs. We have a total of 20 spaces, which we'll get to in a moment, but since that is less than 25 spots, ADA requires that we have at least one accessible parking space. Also, COSA Code of Ordinances requires that every principal building on a lot has a minimum of 2 parking spaces. Now, with those requirements, we have the red outline section. This is the back of our fire station for employee parking. These 15 spaces satisfies the requirement of 12 employee spaces. Here outlined in green, we have 3 visitor spaces. This satisfies the requirement of having 2 from COSA Code of Ordinance. And here outlined in the blue, we have 2 ADA accessible spaces. This satisfies our ADA requirement. Our parking stalls will be 9 feet wide and 18 feet long, also according to COSA specs. However, the ADA accessible, while they will be 18 feet long as well, they will be 12 feet wide and have a 5-foot wide landing. The curb design specs that we used a 6-inch standard curb. This will be where stormwater runoff will be directed to. This will be the gutter line that takes the water, essentially. We have a 6-inch spill curb and gutter. The spill curb spills into the standard curb. And then we have a 6-inch sawtooth curb cut. This is if you're looking at the curb, the curb cut, and then this is a cross-section view of what that curb cut would look like. And those are just for drainage purposes on the north curb line of our site. For the driveway design, since our client wanted 4 engine bays, we found that 66 feet would be required for the fire truck entrance and exit. Noticed here onto front road, the same would be for Ben Ficklin as well. And then we found, according to COSA specs, that we need a 24-foot wide drive. This would be 2 travel lanes for our visitor or employee driveway. If you notice here, we have a minimum radii of 15 feet according to TxDOT standards, and frontage road is indeed a TxDOT roadway. And the median width has a maximum width of 15 feet. We used 12 feet so that we could clearly indicate the difference between these two drives. For our pavement design, we followed, like we said, ACI 330R, so ACI codes. Now, first we had to determine the existing soil in the area. We did this and we found that a sand level with moderate amounts of silt and clay. This gives us a K value of 130 to 170 PCI, or pounds per cubic inch. We used K equals 100 PCI to be conservative. More on that here in a moment. To find our ADTT, average daily truck traffic, according to Emergicon, the San Angelo Fire Department services 15,000 calls per year, approximately. Now, take this 15,000 yearly calls and divide it evenly among the 9 fire stations. Then divide it according to the number of days, and we can find that we have an average daily truck traffic of approximately 10 trucks. Then, using a compressive strength of concrete of 3,000 PSI, pounds per square inch, we get a modulus of rupture of approximately 500 pounds per square inch. And this gives us a recommendation of a 6-inch concrete slab. Shown here. I mentioned that we use the K value of 100. That is due to this table in our ACI codes. Our value that we found of K was between 130 and 170. However, we were given 200, 150. So we were conservative and used a lower value of K equals 100. Our modulus of rupture was 500, and our average daily truck traffic was 10. This gives us a pavement section of 6 inches. Our concrete pavement is 6 inches, and underneath that will be an 8-inch subbase of sand and gravel. And then below that is our existing. Now, the next 3 slides will be cross-sections of our site. The first cross-section will be of the fire truck driveways, outlined as number 1. Secondly will be our public drive, or our employee drive, outlined as number 2. And then the third cross-section will show where the driveway, the 24-foot driveway, meets the 18-foot parking space. As I said, number 1 is the fire truck drives. As you can see here, we have a 66-foot face-a-curb to face-a-curb. This gives us 16.5-foot lanes for 4 engine bays. And then we have a high point of elevation sloping down to a low point where drainage will flow. Secondly, we have the public drive, or the employee drive. A 24-foot face-a-curb to face-a-curb, which gives us 2 12-foot travel lanes, and again, a high sloping down to a low point so that we have adequate stormwater runoff. And then we have our proposed 44-foot face-a-curb to face-a-curb. This consists of 2 travel lanes for the driveway and the 18-foot long parking space. Now, in between these 2 would be a valley gutter, so that water is not in the parking space, it is not on the drive, it has a designated section to drain. And here's a finalized overall view of our site layout with our 66-foot drives, our 24-foot drive, and our required parking. Now, for the environmental section with Will.
Going into our environmental scope, we are to provide to our client the impacts of the environment that our project will have, as well as any required documents, primarily from TCEQ, the Texas Center of Environmental Quality, and an erosion control plan for the project itself. So for the design standards, we once again go from our design manual from the city of San Angelo. We primarily looked at how the water runoff erosion control, such as the flow, not having a flow of 12 feet per second to reduce erosion from our site. We are also going to use a silt fence design standard from the city of San Angelo, which we'll talk about in a bit. For the TCEQ, we looked over the Stormwater Pollution Prevention Plan. For the Stormwater Pollution Prevention Plan, it is a document that has the environmental engineer going over any pollutants either caused or at the site itself, and having that engineer explain how those pollutions will be regulated, removed, or completely removed from the site, and every type of erosion control plan that will be implemented at the site. The three main pollutants of the site is concrete, trash, and oil/grease. The pollution for concrete is produced by our pavement design. As you all know, going through transportation, our entire pavement area, as well as curb and gutter and sidewalks, is going to use up a lot of concrete, which could cause detrimental effects on the environment of our site. For trash, that mostly comes from the initial landscape. It's mostly been open and barren, leading to either a few residents or just the wind leading a bunch of trash on the site that will need to be picked up beforehand. Development can even begin. And then for oil and grease, that comes from our construction team. The heavy equipment, the trucks moving in and out, there's a high possibility that we might have an oil leak or just grease might be spilled on the ground, and we have to regulate that so we don't have a hazardous waste situation. So for our erosion control methods, as mentioned earlier, we have the silt fence standards from the city of San Angelo, which mostly mentions having posts about 4 feet wide with a reinforced fabric mesh covering the front of it to collect runoff coming from our site. We also have a concrete washout area, as many concrete trucks bring in more concrete than required, so that leave the site unfinished, but will then need to be washed out. We'll implement a concrete washout area for those trucks. We will also have a construction drive entrance, which will include a gravel bed. So this is mostly for like any trucks or equipment that are entering or exiting the site, not carrying any soil pollutants or any soil out of the site and draining it all over the road, leaving it on the road. We'll also be requesting that the construction team provides weekly equipment checks so that if any oil is missing or if there's any grease being laid on the ground, why is it there? What can we do about it? Do we have a hazardous waste situation? We were also asked by our client to provide landscape recommendations, primarily landscape styles that have reduced, that are water conservative, reduced water flow, and reduced maintenance for the team on site. Now, the recommendations that we would like to provide is xeriscaping, which is more of a San Angelo-esque look to the site. It has nice little rock beds with conservative semi-desert-like plants such as avages. Pardon my terminology. We will also like to implement a modern landscaping style. It's a minimalistic type of landscaping style with, as you've seen, the nice grass lawns with a few small trees. It just shows off a nice clean environment for anyone passing by. Here you can see a map of our erosion control. The light blue shows the line of the silt fence. It's going to be primarily placed in drainage areas. As you can see, we have some lining this area with the existing retention pond, and this small area where we proposed our drainage-free frontage is going to be. Then the purple areas represent our construction entrances. We're going to put them on each sides of the roads, as that's primarily where all the trucks and equipment are going to come from. And then see here is our concrete washout area. It's going to be on this corner side of the site. Primarily, it's just so that the concrete trucks, if there's any washout, it's not going to primarily be any of the other pavement areas. You know, it's not going to be washed out here or up here. It's gonna be right here, so the truck can just pull out right here and start driving. Moving to construction portion of our project, we are meant to provide to our client the project timeline as well as an opinion of probable cost for the project. Now for the timeline, we go through the pre-construction, construction, and post-construction process. For pre-construction, for the entire project, we believe it will take about 2 years. And we also, though we are only focusing on drainage and the transportation, aka the parking layout, and we didn't deal with the building, we still implement the time it will take to build the fire station within our timeline, so that we can take an outward look going, oh, at this date, we'll start doing concrete after the building has been built. For pre-construction, we give it about a month. This is mostly to set up meeting times with the contractor and the client, as well as getting all the material position, doing some mobilization, and setting up environmental erosion control. For construction, we believe this will take about 22 months, which the primary amount of that time is mostly going to be excavating as well as the building itself, with the building taking about 18 months to build up, which includes foundations, utilities, and the full upward stir of the site. We believe that for concrete placement, it's going to take about 3 months for the entire site, as we have a lot of concrete that needs to be placed. This is also including the fact that it takes about a week or so for the concrete to get where it's walkable, and even a longer time just for trucks and other equipment to be even driven on that road. We will also be emitting, though not shown here, about a month of just landscaping and environmental setup. For post-construction, we are going to give that about a month, which is mostly dealization, doing tests and inspections on the site, making sure nothing's going too fast, water is flowing where it needs to be, and all roads follow TxDOT standards. And then within that post-construction will be about a week of close-up, which is just acquiring all the documents for the site.
So, although on our timeline, we did include the building, the fire station building itself, on our cost estimate, or our opinion of probable cost, we are not including the fire station building, but rather just the civil design services, just the site development. Now, we have a mobilization of 5% of the total cost. This comes from 3 subsections or subcategories. The first being our materials category, which is $2.5 million. Now, noticeably, this red little cell up here, this is the cost of the amount of cut that will be from the site. So we mentioned beforehand that grading the site, it's at a quite high elevation, but due to design constraints, we had to decrease that elevation. So we'll have roughly 1.5 million of our cost pertaining to just the cut, the excess cut on our site. For environmental costs, we found roughly 30,000 to be the total, and our total transportation costs to be approximately 72,000. This brings our total site development cost to be $2.7 million for the project. We want to give y'all a thank you again, and a special shout out to Dr. Pignon, a senior advisor and a HE for hydrology and hydraulics. Also, thank you to the City of San Angelo Engineering Department and Colin Baggett. And also thank you to our client for giving us the opportunity to work on this project. Any questions? Horacio.
Is there a reason why it shows 90-degree parking for the fire station?
Yes, so do you want me to go to a slide?
You can explain it to me.
Yeah. So with 90-degree parking, you can turn in from both ways. Since we have a 2-lane, 2 travel lanes, we figured it'd be easiest if someone is pulling in or backing out, that they can come from either side.
So you're expecting that the employees will actually come in from the west side something?
No. Well, I guess
I'm guessing they will, isn't
they
it?
probably, you are correct, they probably will, because I
We'll
know.
take the easiest, shortest route to
Yeah.
get.
The most
That's
efficient
the way to
method
come
of
in that way.
travel.
Law of energy.
But that probably be up to, whoever's in charge. Someone would have to tell them, like, no one's allowed to enter from Benficklin. Yeah.
I had a question. So the 15 yards of cut was cheaper than putting in a storm sewer to direct the water to the pond?
So, not necessarily, less expensive. We think that there's a possibility of that. However, we were bound by our property limits. So, discharging the storm sewer into, essentially someone else's property, that was kind of one of our constraints.
And a follow-up question on that, do you think that because you will have to increase the area on the east. So do you think by doing that?
Can you give us a site plan? What we're talking
Yes.
about?
You think that you will impact runoff also on the east, by not having the big drop of the big cut?
That is true as well. So, we wanted to grade to send as much water to the retention pond. If we didn't, and we had kind of similar to existing conditions, we would actually probably have to maybe design some stormwater drainage system near frontage, and then again, we have more property line. But yes, you are correct. That would increase the total drainage area going east. Yes.
TxDOT's been converting two-way frontage to one-way for safety. Was that considered, with the egress and entrances?
So yes, I'll go to this, yeah, this one's good. We did consider, we considered a couple of different options. One of those being, I actually want to show, give me 1 second, I'll use this one. One of the options we considered was having a cut right here. So instead of just having the curb cut for drainage purposes, we considered having a cut here, so that if someone turns in, that they could drive to they could reroute essentially. We also considered pulling this median back a substantial amount to kind of give an element of having one frontage drive to frontage. However, we wanted to maintain. We thought it was best, but also our client wanted a median in between, and so we found that this was the best design.
So what I'm saying is potentially that's gonna be southbound only. And for the fire department to go north, they'd have to, in a sense, make the block.
Oh, you're saying frontage road is, okay, I'm sorry. I was
Potentially could be
unclear.
one way, south.
It's gonna be one, okay. I'm sorry, I was unclear on the question. We didn't consider that. I don't think we were aware.
So related to that, I perceive problems with that dual driveway. I predict the average person visiting the fire department, screws up and ends in the traffic lane for the fire truck. So did you, is there a particular signage requirement there or something that's gonna, I mean, you can have this huge 64-foot driveway, and you can have this 20-foot driveway right next to it. And particularly for somebody coming southbound on the frontage road, I presume visitors don't come there very often, and when they do, I don't know what percent of the time they're gonna end up in the the fire truck lane, but how did you consider that? How did you deal with that? How did you spoke a little bit about it, about like you didn't put a relief for them to reroute themselves into the appropriate lane. It just seems like that might be better to me. I don't know, how did you come to that decision about, the dual lane there? Strikes me as, you know, you have this constraint from the property you gotta deal with, but it strikes me as a problematic area.
And you're exactly right, it definitely was a problematic area. It seems like every design option considered had significant cons. So yes, as we mentioned, we did consider an option of having this relief area in case someone turns in. After talking to our client, there was an agreement that that wasn't needed, or that maybe not needed, but it wasn't wanted. So our thoughts were that if someone turned in, the added width of the driveway for the fire trucks gives adequate distance for someone to recognize their error and to turn around.
And did you consider just a one-way flow of the traffic, instead of a two-way flow for the employee and visitor? You didn't want them going back out through Ben Ficklin?
Yeah, we didn't want them going out back through Ben Ficklin, because if you notice here, something that wasn't mentioned, this is a fence, so this can actually be closed. So the fire stations should see no through traffic, and we wanted to ensure that traffic went down to Crossings Avenue around and did not cut through the station essentially. All employees should stop here and not really cross this boundary, and then all visitors really have no reason crossing this boundary.
Is there a signage somewhere for, like, if a visitor was to pull in, to know that anything beyond that gate, like employees only or something, to prevent them from continuing on around? I'm sure we would have a sign that says employees only beyond that point. So if a visitor was to show up and park, they would park in the visitor parking, and then just know they would exit out the same way that they came in.
Yes, sir. We do not currently show
Yeah,
one, but
we would, yeah.
but there would be one, yes, sir.
Did you do the signage plan?
We did not, sir. It was not in our scope.
That's fine.
Question for Will, you have very good drainage calculation. For the current, one of the concerns, the neighbors being concerned with the increase in flooding to the neighborhood on Pecan Road, I think, was the name?
Yes, sir, Pecan Valley.
Pecan Valley, do you think, based on your calculations from the current, the existing site and the pond, do you think that the flooding, that their issues are coming from this side or not?
From our design standards, from our catchment, I'll quickly just jump through one of these. From our existing catchment, there were some worries with these existing retention ponds. As mentioned earlier, it is very much not from our design itself, but was designed by someone else. With how big the catchment area we predicted, we believe that retention pond itself is a lot bigger and hold a lot more water. We haven't really done any design standards to figure out exactly how much water flows into Pecan Valley, but we don't believe that exactly the flow problem comes from just this retention area. We do believe that later on in the future of development, there may be a situation due to the culvert size and the amount of flow that's able to go through it, as the retention pond has a certain problem with retaining water with its design structure. However, currently, we don't believe it should primarily come from this site area for existing, and hopefully for our proposed value, it shouldn't cause any drainage problems from there.
Related to that, is it a retention pond, a detention pond? I always get them confused.
So the fun thing about our retention pond is that For a detention pond, normally it's like where the culvert would be placed at the bottom of the pond itself and would drain out all the water, meaning no water would be staying within the pond. But the pond itself would be able to hold a certain volume of water while it's being discharged to the culvert. Now, this would somewhat seem like a detention pond, but actually, I don't know if you can really see it, within within this pond, it is actually a retention pond, because below the culvert, there is a small swamp-like area right below it. So it is a small amount of water. We weren't able to get any surveyors out there to figure out how deep that water is, but we say that it is holding some water in there.
That's a really huge, I'm sorry, go ahead.
Oh, is it a problem, like, is it on our property, or are we allowed to dump into this?
It is not within our property. We are not able to dump on this site. We're not allowed to mess with the retention pond itself.
Is it capturing water from our side?
Oh, yes, it is capturing water from our catchment.
We were informed that we were allowed to direct stormwater drainage. That's it, even though it is not our problem.
Can you, go to another, 3 more, where you have the inflow, outflow, hydrographs?
Yeah, these are hydrograms.
The routing, sorry, the routing.
The level routing with the culvert, is that?
Yes, if you notice in pre-development, you have a culvert discharge of 1.31. So basically, that's what's coming out of the site, right now?
Yes, sir.
So could that help you answer the question of neighbors, that, so the neighbors are not that concerned with our site?
Yeah, currently our site doesn't have, what doesn't discharge at a high enough volume as
Will they be worried when it's 6 point?
we believe there might be a little bit of worry. The flow, we don't believe the flow would be too much of a detriment, but it's still, obviously, numbers still go up, so there'll still be some worry, like you mentioned.
But it meets the standards.
Yes, sir.
Good.
The outflow of our site matches the outflow, the proposed outflow matches existing outflow, or similar.
Could you go back to your existing drainage area, Matt?
Yes, sir.
Why didn't y'all, take into account the south portion of the site as part of the existing drainage area? Because, I mean, you have your areas that are basically just on the northeastern corner. So my question is, obviously, that's part of your site in terms of permitting and what the city standards are required. Why didn't y'all take that discharge off your site into account?
So, to be completely honest, that was an oversight at the beginning, unfortunately. However, thankfully, if you notice our proposed, we significantly decrease the area that would be heading southward to that. There's actually a culvert that runs and keeps going south along Ben Ficklin. And so, although it was an oversight at first, we significantly decreased the area going south, and so we would decrease stormwater runoff in that direction.
Would that have increased your existing, Q value if you incorporated that one in for your pre and post conditions, making sure they're equal? If you would have done that on the existing side?
I'm not exactly sure I understand your question.
Essentially, if you just included that southern calculation in terms of your total runoff of your existing value and compared it to your post runoff value, would that have increased your existing, therefore making you to increase your proposed to maintain, mitigate the two to make sure that you have that?
Yes, sir. Yes, sir.
Will, do you wanted to add something?
No, I'm just making sure. Yeah, because the total flow, yes, it will increase, and it's just based on the mass balance equations. Yeah, it would definitely increase the flow, but we believe that our proposed, as Josh has just mentioned, our proposed flow rates they would still come out with the calculations we have.
But just to clarify, Will, is that part of the catchment, or that's a separate catchment, the south one? What is happening there?
What does that mean?
Especially the white catchment.
The white catchment, to the left, yeah. Right.
Like are you asking if it's part of our area?
It's part of your area, but is it part of the yellow catchment, purple catchment, or is it a different catchment?
Oh, no, this would have its own catchment, as mentioned earlier, we didn't look into it, but then with our new catchment, it would reduce, we know it would reduce the area as this area over here, which would normally flow down here, we take that up with our site.
Thank you.
All right, I got two geotech questions for you.
Yeah.
So one is, you said, you believe that the source of that high point in the center of the site was, filled from a previous what I would call uncontrolled fill. There's no reason to think that it was, it was controlled, right?
No.
Did you estimate depth of that, and does your grading plan get you below that to native soil? Do you know that, or because if you don't do that, then you're gonna do over excavation recompaction if there's uncontrolled fill, because you're not gonna be able to put the building on controlled fill. So, did you look at that, and if you didn't look at that, did you have been at the site? Do you have a feeling for that?
So, we didn't spend too much time thinking about that. My only thoughts along those lines, during grading were kind of, if you think about it linearly, so existing elevation from frontage road is 1876 and a half or whatever. And then existing elevation on Ben Ficklin ranges from 1869 to 1871. So a decrease in 5 feet. And so just considering that, if we hypothetically say that the natural ground, not including the, you said unsupervised? Uncontrolled fill, it would bring us probably near, but we're not exactly sure.
How would you deal with that during construction? That issue that, I mean, right, I'm just asking you how you would deal with that as an engineer. If you didn't know, right?
So I would handle it the same way that you would probably handle any borings. I would take samples of surface conditions because we know that would be the controlled fill. And then as we take borings at certain depths, we'd return soil logs and we'd just do a comparative analysis to figure out if, just basically as it drills down, okay, is this matching? Oh, it's matching. Oh, we're not matching. We probably hit what was there before.
And I don't know if you didn't discuss it, did your grading plan, are you getting down to the, I'm presuming the building's gonna go on shallow foundations and there's gonna be some structural fill below, for the floor slab, if nothing else.
Yeah.
So did your grading plan just take you down to where they're gonna put that fill, or did you have that structural fill for the fill in your grading plan?
So,
Because, I mean, just for drainage purposes, the building's gotta be higher than everything else around it, right? So you just
Right.
did you consider the need to do a structural, even if you're gonna put your shallow foundations on native material, you're gonna have to place a fill for directly below the slab, right?
So we determined, basically during grading, it was just an iterative process, trying to determine what finished floor elevation worked
Okay.
with all of our constraints. And after we found a finished floor elevation, that we just said that's where the building slab will lie.
Right.
Everything underneath is up to the geotechnical.
Your grading
If I
plan takes
understand-
to just below the slab line.
I'm sorry, say that again?
So your grading plan, you're assuming everything goes on, to put it simply, everything goes on I'm gonna say soil. You didn't grade below that and then in fact 6 inches of gravel or whatever subgrade you need for the subbase you need for the.
No, we didn't. Yes, sir.
Other than elevation, your foundation building are probably under the structural architectural design, probably smart.
Yeah, I'm just trying to figure out where the grading plan went to. So go to slide 17. In fact, there's even, I'm looking at the slope at the north end of the site there. And someplace you have an even bigger, where you have the channel design, no, you right there.
Yeah.
So how steep is that slope, and what's the total elevation change from the toe to that top, to the head of that, crown of that slope? And how steep is that slope?
So currently this slope is, the grading plan shows a 3-to-1, but after I add the rectangular flume, then that will increase to 4-to-1 slope.
Are you concerned about that for erosion or any other purposes? And do you need a retention system there?
Well, if we're less than, after adding the flume, if we're less than 25%, I'm not concerned about erosion.
I think this is a good time to wrap the session, and thanks again. Let's give him a round of applause. Well, we will collect for the practitioners, we will collect the forms, and we thank you for coming to this semi-annual event, and we will wait for you for the next semester. Congratulations.
Thank you all again.
Why do you think that retention time is there? Why is it? It looks like it could just be a sand pit.
No, but we think there was some areas, the topography was different back in the day, and it was a much bigger drainage area draining to that.
Congratulations, yeah, this was very impressive.
Thank you so much. The form is excellent, and one to 4, but not